Hey guys, in today's video I'm going to teach you how to interpret Mari part 2. If you haven't watched part 1, check it out. There's a playlist for it and let's get straight into it. Now, in this question, it says given the binary data at right, interpret it and construct a Mari source code program for it. Use single letters of the alphabet, start at A for memory location values. Assume the direction org100 was given as directives among assemblies, and those the first line is at memory address, whatever this is. So the first thing is to group each of them in fours, right? 1, 2, 3, 4. And if you remember correctly, the first 4 digits here are the opcodes. So those are the instructions from Mari, and this is the address. Okay, so let's get to it. Anyway, you see this first digit, this represents the opcode, right? But we need to know what decimal each of this thing gives, right? Each of this one to give. And how do we do that? Now, because I used to this, I can tell straight away that 0001 is 1 in decimal in base 10. But for you guys that don't know, find the binary form of 1 to 14 separately and just use it to know which digits these ones are. Or if this is an assignment that you're trying to complete, you can always go online and just check for binary to decimal, an online converter, and just do it there. If you check here 0001 and you convert it, that's equals to 1 in decimal. So we know this one right here is equals to 1. So we're just going to do this. I'm going to put 1 right here, and t equals to 1, 0, 0, 0. I just want to confirm. 0, 0, 0 equals to 0, 1, 0, 1, 0. 1, 0, 1, 0 is 10 in decimal, that's base 10, but this is an hexadecimal, so 10 is A, so we're going to put A right there. 0 is going to be A, 0, 0, 1 is 1, 0, 0, 0, let's confirm, and 0, 1, 1 should be 11, which is B hexadecimal. Now, if you guys don't know how to convert base 10 to hexadecimal, if you don't know, I'm getting A, B, I have another video on it in the playlist. Check it out. 0, 1, 1 is going to be equals to 3. So yes, 3. 0, 0, 1 is 1. This is 0. 12, so 10, 11, 12, ABC, that's C. 0, 0, 1, 0 is A, 1. This is 0, 1, 1, 0, 1 is 13, so that's D. 1, 0, it's A. 0, 0, 0 is 0, and 0, 0, 0, 0, and this is 0. Check it out. 6. So this is 6, 0, 0, 0. So 0, 0, 1. That should be 15. So this is F, which is C. This is 0. That's 40. The first 4 digits are the opcodes, and 1, this whole thing means 1, But before we get there, I'm seeing a mistake somewhere. That is here. This isn't A, it's 2. So I'm sorry about that. That is 2. And this 1 is the opcode, and we're going to go here. That's a Mari instruction set. And 1 means load. So we're going to say, well, we have to start with org 100, and we're going to say load A. Now, what is A? A is the hexadecimal values 108. And in order for us to do that, we have to store it in a memory location. Now, how do we know this is a memory location? That's because the first 4 digits are all 0. So we're storing 10A in this memory address, and so this memory address is gone. So we can now say A, and it's going to be hexadecimal, and we're going to store 10A. Or let's just put it in capital letter, makes it neater. All right, the next one is 2. And what does 2 mean in this? 2 is store. So we're going to store, and what are we storing? We're storing 10B. So we're going to store B, and what is B? B is 10B. So we have to assign 10B, and we have to take off this guy here. So that memory address is gone. So we have 1, 2, 3 remaining. And what's the next one? 3. What is 3 in Mari? 3 in Mari is add. So we're going to say add C, and what will be C? C is going to be 10C. And we're going to take this memory address right here, and we're going to remove it. So we only have 2 memory addresses, or 2 memory locations left where we could store things. And what's next? A. What is A? A means clear. Clear. Usually, I would say just write clear, because it's meant to be A00 to be specific, to be correct, but we're just interpreting the Mari code. It doesn't have to work. Most of the times, not going to your professor trying to know if you can interpret Mari code if he gives it to you. So now A110D doesn't make sense. This is not meant to be allowed, but just to fulfill all righteousness, we're going to say clear D, and we're going to come here and assign 10D to it. We're going to come here and take one memory location. Now we have A000, which means clear, and we're going to write clear. We don't have to put anything here. We don't have to assign equals all zeros. Then we have 6000, and what does that mean? 6 in Mari means output. So we're just going to write output, and we are done. So this is the correct answer to this. Everything here is equals to everything here. We have one extra location left. You don't need to assign it to anything, but if you want to, you don't have to, but if you want to, you can assign it to anything, but it's not necessary. But for your sake and my sake, don't do it, because your lecturer may fail you. Now, if you found this video useful, make sure to leave a like, subscribe, and turn on the notification. Thank you.